Hey guys, welcome back. We were dealing with the naming of the organic compounds, and we have completed the naming of alkanes. Rather, we have started the naming of alkenes. Okay, so first of all, guys, don't forget this thing that what were alkenes? These are the compounds which we have said that these are the unsaturated hydrocarbons. And number 2 point is this, that they have all carbon carbon double bonds. At least one carbon carbon double bond must be there in case of any alkene. And one more thing was this, that they have a general formula of CnH2n. So these are the informations which we are dealt already. And one more thing with which we have dealt, that is the reactions of the alkenes. Addition reactions are shown by alkenes, whereas substitution reactions are shown by alkanes. So in case of alkanes, if we are going to discuss the whole thing, for example, we have started this thing of alkanes and alkenes, and we are done with the basic concept. Let me go there. Okay, so this is the basic concept of organic chemistry which I have started. I have told you what's the general formula, what are the homologous series, properties of the homologous series, what is the functional group, different types of the families of your syllabus, that is the different types of the general formulas of your syllabus, their general formula, their functional group, number of carbon atoms and the names associated with them. Then afterwards, homologous series, their final family name, in, and ol, etc. This is in, guys, this is in. Okay, then move to the alkanes general formula. They all have carbon carbon single covalent bond. This was the exceptional case in this. Here the general formula, how to derive the formula from the general formula. So these are the physical properties of the alkanes. Then we move to the chemical properties of the alkanes. We are done with the combustion and cracking, free radical substitution. I have told you that we will teach you in AS level. Catalyzed cracking, or that is the catalyzed cracking and substitution here. That is the combustion, sufficient supply of oxygen and insufficient supply of oxygen, complete and incomplete. That we are done with. Different examples of combustion are done as well. Then the cracking thing, that is the long chain hydrocarbon, long chain alkane is going to shift itself into alkene and alkane. So these are the conditions for that. And here we move to the basic concept of alkene. We should know this thing, that what is an alkene, so that we may crack down a compound into alkene and alkane. Here the combination of C8H18 going to give you shorter chain alkane and shorter chain alkene, along with the other combination is shorter chain alkene and hydrogen. If alkene is producing, hydrogen will be produced. One should know this thing, that what are the benefits of cracking. Uses of cracking are to produce shorter chain alkane, shorter chain alkene, and hydrogen. This I can write over there as well, so that if anyone is confusing in this, that what are the uses of cracking. Number one, shorter chain alkane. Number two, shorter chain alkene and alkene. Okay, and a shorter chain. And number three is hydrogen gas as well. Guys, can use this hydrogen gas in Haber's process to prepare ammonia. So don't forget this thing, that while preparing ammonia in Haber's process, examiner asks this question, that what is the source for hydrogen. It will be obtained by cracking of alkanes. Okay, so these were the products, these were the uses to do the process of cracking. These are the different examples. Here we are dealing with substitution reaction. The examples of substitution reactions are here. And I have told you that it is a stepwise reaction. Number of steps are based upon the number of hydrogen atoms, and it is happening in the presence of ultraviolet radiations of sun. Okay, or if it is not available, then obviously the ultraviolet radiations that are the artificially created in the source of ultraviolet radiations is placed in the lab as well. Okay, so this is the reaction of methane, and I have prepared different types of the compounds here. I am continuously doing this here, and afterwards we move to the next example of substitution, and then we move to the next thing, and that is related to, here I'm moving on to the next part, so that we may be on the same thing. These are the past paper questions which I have solved. Okay, these are also in the recorded videos. This is the alkene, that is the second homologous series, their names, and what is called catenation, what is saturation test, and And after saturation, we were moved to the next point, and that is related to this. These are the different questions related to the saturation. After saturation, I have shifted you people to the reactions of the alkenes. After reactions of the alkenes, we have moved to the namings of alkanes along with the topic of isomerism. So here I am going to discuss the naming in case of alkenes today. Guys, for example, this is a compound of two carbon atoms only, and we know this thing that each of the carbon atom has made double covalent bond already, so it is going to make two hydrogens bond here, two hydrogens bonded over here. So what will be the name of this compound? It is called as eth-1-ene. Why it is so? Eth means it is a compound of two carbon atoms, and one means at position number one there is a double covalent bond. So we can call this as position number one, and we can consider this as position number one as well, or one this and two this. So vice versa. It is depending upon you, as double bond is on the preferred level. From this way, it is on the carbon number one. From this way, it is on the carbon number one. One more thing, for example, if the double bond is between 1, 2, 3, 4, 5. Okay, so for example, double bond is between 2 and 3. We are saying this is number 1, this is number 2, this is number 3, this is 4, and this is 5. We are saying that double bond is between 2 and 3. So here we are going to say it 2. So remember this thing, that what is the rule for naming of an alkene is select the longest carbon atom chain having double carbon bond or carbon carbon double bond at the smallest number, at the smallest possible number. And one should know this thing, that when we are dealing with this smallest possible number, one should give the smaller one. I mean to say, if it is between 3 and 4, we will say that double bond is with carbon number 3. If it is between 2 and 3, we will say that it is with number 2. So here I am on the next page now, and that is this. For example, okay, I am going to give different examples for this. This is this 1, 2, 3. Okay, I should give the name to this first of all. Okay, so what will be the name of this compound that is written at the bottom? It will be called as pent-2-ene. Why it is so? Pent means 5 carbon atom chain. At position number 2, there is a double covalent bond, so that's why it is called as pent-2-ene. So ene means carbon carbon double covalent bond, which is present at position number 2. So here I'm going to tell you another name, and that is one position. Okay, so what will be the name of this? And this is present over here as well. Okay, so what will be the name? For example, it is if we are counting, it has a double covalent bond. I mean to say, two times double covalent bond is present in this compound. So such type of compounds which have two times double covalent bonds, that is called as diene. And if there are three times double covalent bond, then that will be called as triene. Dienes and trienes are not part of your syllabus in detail, but sometimes examiner can give a question related to this by giving sufficient information from which a student can have an idea that this can be a possible answer. So what will be the name for this compound? It is called as number 1, 2, 3, 4, 5. So the double covalent bond is between number 1 and 2. Double covalent bond is number 4 and 5. If we are starting counting from this way, again it is the same pattern. So it will be 1, 2, 3, 4, 5. So it will be remain same. That's why we can start counting from either of the side. Okay, so what will be the name for this compound? It will be called as pant dash 1 comma 4 dash diene. So guys, the double bonds are between 1 and 2, so we are considering it 1, and the double bond is between 4 and 5, so we are going to consider it 4. So these are the points which you need to keep in your mind, that where we are going to consider the double bond and what is the way to give the name. So for example, consider another example, this. Okay, and it has this as well, and it has this, for example. Okay, now I'm going to write down the hydrogen atoms, so make a more elaborated thing. Although I have not written in two or three examples, but you should know this thing right now after this much practice, that where we are going to place how many hydrogens. Look at here right now, I'm just giving you a reminder. This carbon atom has made 2 bonds, so it is going to make 2 more. This carbon atom has made 3 bonds, so it is going to make 1 more. This carbon atom has made 3, so it is going to make 1 more. This carbon atom has made only 2, so it is going to make 2 more. And what about this carbon atom? It has made only 1 bond, so it is going to make 3 more. So these are the concepts about which we should have an assurance. I am writing here H2, it is called H, it is H here, it is H2 here, and it is H3 here. Okay. So what will be the name of this compound? It will be called as 3-methyl. So at position number 3, there is one carbon atom branch. That is, one carbon atom branch is called as a methyl. Two carbon atom branch is called as ethyl. Just revise that alkyl radical, alkyl thing information. Alkyl radical, the word of alkyl radical will be taught to you when we will when we will teach you the concept of substitution reaction, free radical substitution reaction in AS level. But right now, you may consider this that is an alkyl basically. And what is an alkyl? When we are subtracting one hydrogen from the respective alkane, it is giving you the alkyl. So it is called as 3-methyl pent 1, 2, 3, 4, 5. Okay, 3-methyl pent dash 1 dash ene. So this is the name of this compound. Okay, so it is carbon number 1, carbon number 2, carbon number 3. At carbon number 3 there is a branch. Okay, carbon number 4, carbon number 5. So at position number 3 there is one branch of one carbon atom. So it is called as 3 dash methyl pent dash 1 dash 3 dash methyl pent dash 1 dash ene. So this is the name of this compound. I am going to give you one more example for better understanding. You may consider this compound as an example. Okay, so this is this and this is this. Okay, remember this thing that double bond will never be a part of a branch. I'm writing this thing as well because double bond should be part of the parent chain. Parent chain is the one which is the main chain. Okay, so for example, if you are going to consider it as a branch, the double bond can never be at this place, can never be at this place. Okay, so double bond should be part of the main chain. If for example double bond is here, then you have to consider this as main chain. You have to count like this, or you have to count like this. Okay, then you have to consider this thing, that what will be the name of this compound. So here in this case, what will be the name? For example, we are writing this over there and we are writing this over there. So what will be the name in that case? So it is 1, 2, 3, 4 and 5. So you can see this thing that each of the carbon atom has made few bonds. So what will be the name? It is called as 3 comma 4, or it is called as 2 comma 3, because we are going to move from the other side. But in that case, the double bond will get the bigger number. So that's why it is advised to move in this way. So it will be 3 comma 4 dash dimethyl pant dash 2 dash ene. So this will be the name of the compound in this case. This is the way to give the names to the organic compounds in case of alkenes. All right, guys, take care of yourself and make a practice from all of these videos as many times as it is possible, because things will become clearer and better with the passage of time. Obviously, after finishing all these content related to videos and stuff, I will discuss the past papers as well, inshallah. All the best to all of you.